Homework solution 2.1. Using your understanding of phasor diagrams, determine the complete phasor voltage for each source and for the combined sources for each of the three conditions given. So the givens in this problem statement are that we know the magnitude of voltage 1 here is 3 volts, and the magnitude of voltage 2 is equal to 4 volts. We don't know anything about their phase angle except for the information that's been given in these diagrams. I'm not going to repeat that in the given statement though. You can see it for yourself. What are we asked to find? Well, if we're going to write out what the voltages are, we need to know what the phase of V1 is. Similarly, we need to know the phase of V2. And then we don't know the magnitude or the angle of the total voltage, so we need to know the magnitude of V total and the phase of V total. So 4 quantities to determine there. The solution to this problem is to go to these phasor diagrams, and you just have to know how to interpret these. By looking at this diagram, we see that the voltages have been drawn in the complex plane, and in this case here, both voltage V1 and voltage V2 are shown to lie purely on the real axis, and we take that visual information and we can represent that as V1 is equal to 3 at angle 0 degrees volts. V2 is equal to 4 at angle 0 degrees volts, and we'll combine that information to see that the total voltage is 3 angle 0 plus 4 angle 0 is equal to 7 at angle 0 degrees volts. So that's just the phasor voltage of the phasor addition of two in-phase voltage sources. Move to this here. This phasor diagram here. We see that V1 again is equal to 3 at angle 0 degrees, but this time we have V2 pointing in the opposite direction. Typically we would write that as 4 at angle 180 degrees. You could have also written it as minus 4 at 0 degrees. Both of those are correct. If we add 4 at 180 to 3 at angle 0, we get a total voltage equal to 1 at angle 180 degrees. All these should have units of volts. The phasors do have units. Again, you could have written that as minus 1 at angle 0, same vector. The third phasor diagram we have, a little off the screen there, is this one right here, where we have V1 is equal to 3 at angle 90 degrees. It's pointing in purely the imaginary direction, so that's 90 degrees. V2 in this case is 4 at angle 0 degrees volts. We add those two together, and we need to determine what the angle of this triangle is. So we can determine phi for V total. That's going to be equal to the inverse tangent of 3/4. Remember, tangent is opposite over adjacent, so the inverse tangent is going to give us the angle formed by the hypotenuse and the base there. And so if you plug that in your calculator, you find out that that's 36.87 degrees. So that gives us a complete expression for the total voltage, not plus, equals, and we've already solved the hypotenuse of that triangle for you. You should know that's a 3, 4, 5 triangle from basic geometry though. So that's 5 at angle 36.87 degree volts. So a couple examples about how the same magnitude phasor voltages can be added together in different ways if they have different phase angles and the different resulting voltages that you can get from those.